They have a terminal bud, and I talked about that on trees a little bit. The terminal bud is at the top of the tree. The terminal bud keeps it growing upwards and keeps the plant growing. Now, if you damage the terminal bud, one or two things are going to happen. One, either the plant's going to quit growing altogether, or two, it's going to bush out. One of the lateral buds will come out and it'll bush out and it'll take over. And either the lateral bud, one lateral bud will take over, or two. And if you've seen trees with two stems, that's what happened. The terminal bud got damaged at that part of its life, and it's sent up two. Subalpine are really good at doing 4, 5, take off and have all the laterals come up and become the main part, or the growing part of the tree, going upwards. And you can see the lateral buds on the sides. They're usually come out of the stem directly, and they're going to be your branches on your trees and your shrubs, or there'll be a second stem coming out of your forbs. And in forbs, they're usually found above the leaf blade. Okay. Let's see. And they also sometimes call them leaf axils. They have a lot of different names for the same things in here, and I'll let you look at it and study it on your own. And what I want to get down into is the roots. Now, there's usually not always, but there usually is what we consider a taproot, which is and has a root cap on it, and that's what's growing down and anchoring the tree or the plant. But not all trees and plants have a taproot, like this one is showing. Instead, they have lateral roots, and they have all lateral roots. You can't tell the main root from any of the lateral roots. And all those roots that go off to the sides and are looking for nutrients, different places, also have root hairs on them, and root hairs are the ones that really go in and find the nutrients and pull them into the plant. And that's where you're going to find your mycelia. When we were talking about funguses the other day, and they're talking about mycelia, it's going to be around those root hairs, and it's going to, and it's also going to be found all over the roots, but it's going to be helping bring that nutrients into the plant. So there's your vascular part. Okay, so there's lots of different types of stems and roots. We have trees, we have shrubs, we have ascending plants, plants that reach up for the sun. We have declinement, they kind of go out to the side, proclinement, they go way out, but they still have a center root. And then you start having plants repent that go out and send out across the ground, and then send little roots out from either little piece. But they don't do it all the time. Or you have, this one's kind of hard to see, I can't remember, Staphyrius, which are like a strawberry, send out runners, and each runner becomes a new plant. Okay, then you have, I'm not going to say all these words because I hate all these big words, but this is basically what a grass looks like right here. This is an iris. This is a good example of this. The corn. This one, the tuberous, is more like a bulb. The corn is more like a lily, and we'll talk about that later. Then there's fibrous roots that we talked about. And that's somewhat what grasses do, but they also do this. So plants can do several things. A lot of your plants, if I pull out that petunia, it's going to have a fibrous root. And then your tap root, like your carrot, your beet, your turnip, with a food storage area. Okay.
What's the difference between repent and stoloniferous? It looks like they're kind of the same thing.
The only thing that I see that's different is in the repent, Not every branch that goes out and has little leaf slits on the, sends out a root. It just does it once in a while. Does that make sense?
Mhm.
And that's all I saw that was different between those. Where the other one sends out, every single one, like a strawberry, if you ever gotten into your if you grow strawberries, you know, it sends out the runner and each one sends out its own root and makes its own new plant. This guy, right here, is kind of a repent, because he's here. Each one, I don't have any, well, let me know. Yeah. So he has roots on some of these.
Yeah.
Now, if this hits the ground, it'll start growing, but he may have some that don't ever do that. Some will just look like this and never really send. These guys need to be taken care of. I wasn't here to take care of them. So. Okay, leaves. Leaves, we're gonna go into leaves a little bit, but basically, a lot of these handouts are for you, to help you learn this stuff. Some of this stuff is on different formats on yours, so just kind of take it apart and go through it however you need. There's simple and compound leaves. A simple leaf is basically a single leaf blade. A compound has several leaves going off the same stem, and when this falls off the plant, the whole thing usually falls off together. And they can be in different shapes. Veination we talked about a little bit. We have the pinnated, we have the, and then we have the palmated, and then non-veined. Basically, it doesn't have a center vein. This is the monocot that has all the ones that are parallel and doesn't have a center. And here's the grass with them all going parallel. Okay, the only reason I put this in is when you get into those books, they're gonna ask you
Yeah.
these terms sometimes, especially in that big blue book, they're gonna ask you these terms. Is your leaf? And there are so many different types of leaf edges. And I can't even remember all of them when I'm out there. Most of the time, I have to come in or I have to take this with me. But I get the biggest idea is if there's nothing on the edge, it's a smooth edge. If it's a serrated edge, if it's a lacerated edge, that's important. If it's a parted edge or a cleft edge or a lobed edge. Those are the ones you see most often. Oh, double serrated. You see double serrated out there. Some of the other ones, you're gonna have, you may look for years before you find a plant with that kind of edge. Your tips are gonna can be very different, and this is important when identifying a plant. And the way the bases as the leaf comes off the plant are different shaped. And you can look at those. And if you think of, if you guys have houseplants like I do, you can think, oh, okay, yeah, I have a houseplant that looks like this, and I have one that looks like this, and I have one that looks like this. Yeah, I have all those. So the way they come off. And so this is just good to take out with you for a while, and you, if you can remember them, help you, especially if you're trying to look through a book, it's good to take this along. Here's other leaf shapes. Here's your grass. Here's a little bigger blade.
This is a good page to have if you're looking at keys.
Yeah, if you're looking at keys, this can be really helpful. Linear, there'll be a lot of plants out there that have a linear leaf. There'll be a lot of have lanceolate. That one I've seen a lot out here. Up here, when you see this, you know it automatically. It's just like, oh yeah, okay. Because if you notice, the center is here, the stem comes up kind of into the center of the leaf, which is really weird. But there's a few plants that do that. Deltoid, Your aspen, right there. Difference between these is the way the veins leave. Same shape, but if the veins come out and branch more often, or if they just come out and branch once. Ovulate, you see a lot of these, and elliptical, you see a lot of those. I don't think I have seen this one yet. I don't think if I ever find one. And then your leaf arrangement coming off your stem. They're gonna be alternate or opposites or whorls. And this was one of the first things it's gonna ask you in those books. It's an alternate. And this tells you a lot. You'll have shrubs that basically both have serrated leaves, and the difference between the shrub, if you can't see a bloom or a berry, is whether these are alternate or opposite. And it tells you which shrub it is, because whether it's alternate or opposite tells you the same thing. If you're getting down to genus and species in a plant, sometimes this is the key factor. Lots of times plants don't have flowers. At this time of year, there's a few flowers out there, but there's a lot that don't have flowers. Most of the time, lots of us wait. It's a lot easier to wait till they have flowers to figure out what they are, but sometimes you have to go find out what they are before they have flowers. This can help you, and that's what the importance of leaves are, and all this leaf arrangement. So that's why I had all those slides. Use those, but they'll help you. And then flower types. There are lots of different flower types. And you have to look at them for a long time before you figure out some of the different spikes and racemes. They look a lot alike when they're out there. You have to figure out what the difference is. Racemes and xylems, there isn't that much difference except for there's more here, and they're a little different. Comberum and uncum, this one has, they all come out. They come to the end of the stem and all come out. These come out. And as you're looking at them from up above, it may look the same. You have to turn it over, the flower over, to look at the bottom to see which one it is. Raceme and panicle. If something's chewed on it, and all these, oops, isn't it? Got carried away here. This one, okay. If all these are not there, if all this part and this part aren't there and you only have this, are you gonna be able to tell that from this or this? It just depends. You have to find the perfect plant sometimes. The head plants are very easy. Those are all your composites. Basically, they're gonna have a flat dish head. They're gonna have rays going out from that head, which are what we consider petals. But each one of those round things are a flowerette, and it has its own stamen and it has its own pistil. So when you see a composite head, and one of the things you can think of right now is a dandelion, think of how many seeds it has. Think of a sunflower. How many seeds can it have on one head? Composites. If you don't want a composite there, boy, you better not let it go to seed because it's going to put out so many seeds that you are going to have a hard time controlling that plant. And if you think of some of our worst noxious weeds, thistle, knapweed, thistle and knapweed are the two I can think of right away. Dandelions, we don't even call them noxious weeds anymore. We just go, okay, they're here. They've been here for hundreds of years, even though they weren't originally. They were brought over probably by the Pilgrims in their hay. Or by the Spaniards.
I always thought it was real interesting. Grasses, almost none of the grasses we're familiar with are native.
Yeah.
You only see, like in the Midwest, there are remnants of native grasses, but otherwise everything is.
Yeah, all our pasture grasses and stuff,
Yeah,
a lot of them we brought over from another country. We said, oh, leaves act like this thing, so yeah, we're gonna plant this. We still have like pine grass here and stuff like that that are native,
yeah.
that were here, but they aren't gonna be what you can't feed your horses or your cows on pine grass. There isn't enough of it.
I guess
This
most
is perfect
natives
now.
are bunch grasses rather than.
Yeah, or bunch grasses, yeah.
rhizomes.
Mhm. But then there are some bunch grasses like
Yeah.
orchard grass, which I don't think is a native, but it's one that we also plant. They used to plant it in orchards because they could pick up fruit underneath it very easily. Oh, I don't know. Hang on, head, see head. So your composites, your whole family with head are really easy. It's a huge family though. It's a huge family. And then your solitary terminal bud, which you can think of as a rose, and your solitary axillary buds, which will have several flowers, which could be your floribunda rose. Yeah. We've changed plants so that they fit what we want. Okay, flower parts. Okay, let's start down here in the corner. Sepal. This is the outer covering. This is usually green, but sometimes it's not. Sometimes it's changed color and is the same color as the petals, or is a coordinating color with the petals, as I always think of columbine, have beautiful sepals that are either blue, red, yellow, something other than green. And then sepals can also have special different attachments, I should guess. Like they can have no, those are in the petals. Never mind. The sepals cover the outside, cover the whole bud. And then the petal is usually colored. And the petal encourages the insect to come to the plant. That's its function, this color. Encourage the insect to come to the plant. Or the bird, or the bat. Whatever's gonna pollinate your plant, the pollinator. The petals there encourage the pollinator to come to the plant. Okay, and those are usually colored. Though every once in a while you have plants that don't have petals. And we'll talk about how they're pollinated differently. Anybody have an idea why they're pollinated differently? If you aren't trying to get a pollinator, an insect, a bird, or a bat to come to your plant, how do you think you're going to pollinate? How do you think that plant's going to? Wind. Yeah. They aren't going to be pollinated. They don't have to have petals because they don't have to have anything that draws it to it. That's pretty cool. The stamen is the male part of the plant. It has an anther where you usually find your pollen, and the filament, which is where the pollen comes out from the plant and sits on the anther. And when the insect or the bird or the bat comes, it gets all full of pollen from the anther. Then you have the pistil, which is the female part of the plant. And it has a stigma, which lots of times will have a sticky substance on it that the pollinator is attracted to. It has it'll have a scent that will attract them to it also. Either, lots of times the scent has to do with the smell of sex in their similar species, male or female, attracting it to it. The style, which is where those juices come up from, and where the pollen falls in and comes down and comes around and goes into the ovum. An ovum is very much like a uterus, and then the ovulate is basically where the seed will start when it gets pollinated, that's